Hello everyone, welcome back to Coding Intuition. Today we are going to solve minimum time to complete trips question on LeetCode. So let us just quickly understand the question. In this question we are given an array time which denotes the time taken by the bus to complete one trip, which is an array of integers, and we have given another integer called total trips. So what we need to do in this question, as we have given a time in which a bus can complete a trip. So we need to find out what is the minimum time required for all the buses to complete at least total trips. So let us just understand it by an example. So in this first example, at time t is equal to 1, we will be able to complete only one trip because our time required to complete a trip for this bus is 1 second and other bus is greater than 1 second. So let us just say it's second, it is a time which is in any unit. So let us just say it a second. So at time t is equal to 1, we will only be able to complete one trip. At time t is equal to 2, our first bus will be able to complete two trips because it completes one trip in a second, and they can just consecutively complete the trips. Okay. And at time t is equal to 2, our second bus, which completes a trip in 2 seconds, will also be able to complete one trip. And at time t is equal to 3, our first bus will complete three trips, and second bus will need 1 more second to complete other, so it will not increment. And our third bus will complete one trip at time t is equal to 3. So at the in total it becomes 5. So that's how we found out the time we need 3 seconds to complete total of 5 trips using these three buses who take this much time to complete the trip. So I hope that makes the question very clear. So let us just quickly jump to point. So let us quickly understand the brute force solution first, then we'll move to our better solution. So in this brute force solution is very much obvious. In this solution, we just need to go through every timestamp until we find our total number of trips to be 5. At every timestamp for every bus, we will find out that each bus, how many trips that each bus can do. So for example, in this, at time t is equal to 1, the first bus can do one trip, second bus can do zero trip, third bus can do zero trips. Because and how we are calculating it, just dividing time by this time. So basically it is a simple formula, it is very intuitive, that time spent by time taken would give us that how many trips are done yet. Okay. So first, and so we will calculate that for all of the cases. As you can see in this code, we are doing the same. We are just dividing current time by the time given in the array, and which will give the time of our current trips. We will calculate every time. The first time current trips will be 1, then it will be 3, then it will be 5, and as it exceeds the total trips, we will know that it has and every time we are incrementing the time, so it will reach to time will reach to 3 up when the current trips reach the total trips. So at that a time we will return the current time, and that will be the time taken to complete 5 trips, minimum time to complete 5 trips. And another thing, that this formula we will be using in our ma- uh, in optimized solution. So this can also give you the intuition how we are going to solve our optimized solution. So let us just quickly jump to understand the optimized solution. Let us understand the small example first. So we have an array which have only one element and our total trips are 6. So in this case, what will be the total time required to complete all the 6 trips? So for every trip we will take 2 seconds because we have only one bus, and our answer will be 6 into 2, 12. Okay. So we can see if there is only one element in array, we can simply multiply it with by total trips and get the total time required for completing these trips. Now let us just add a few elements greater than 2 in this array. Let us add just 5 and 7 in this array. So now, as we can see, 5 and 7 are greater than 2. So will these elements contribute to time or will reduce the time? Will have to reduce the time. So what I want to convey is that in any array, if you find the minimum element and multiply it by the total trips, so your answer will always lie in the range of 1 two total trips multiplied by the minimum element in the. We have a range of our answers, basically range of the total time. We can simply apply binary search to it to find out our final answer, because we already know that we can find out total number of trips at any given time. We have seen that in our brute force solution how we calculate that, and these are just the range of the time. So at any given time we are able to calculate the total number of trips, and we have also given how many trips we have to cover, how many trips we have to completely cover inside the question. So we'll compare with this trip to our total number of trips at any given time, and we will increment our left index if we are less than 6, and if we will decrement our right index if we are greater than 6 to come closer to 6. So let us just quickly run through an example to understand it much better. So now first of all what we will be doing is we will try to find our mid. So 12 plus 1 is equal to 13, by 6 is equal by 2 is equal to 6, so our mid value is 6. So at time t is equal to 6 we will try to find out the total number of trips we can cover. So we can cover 6 by 2, uh, 6 by 5 is 1, 6 by 7 is 0. So we will be able to cover 4 trips here, which is 4 is less than 6. So now what we will be doing is we need to increase our left to mid plus 1. So we will increase our left to 7. With mid is 6 we increase our left to 7. So now our now again we will try to find out mid. So 7 plus 12 is equal to 19, and 19 by 2 is equal to 9. So our mid is 9 now. So at time t is equal to 9, t will be 6 again, because 9 by 2 will be 4, and 5 will again be 1, and it will again be 1, so it will be 6 again. So now 6 is equals to uh, total trip. So when it is equals to total trip, we need to decrement, when it is greater than or equal to, we need to decrement our middle index, because there are the possibilities we can get to more smaller answer in that case. So as we are at 9 now, maybe there is a more smaller time. So at equal index we also need to decrement, because we maybe get to more smaller time. So now we are at 9, so we will decrement it to 8. Okay, so now 8 and 7 becomes 15, which is 7 now. So now our mid is 7. So at 7 we have 5, which is less than 6. So now we will increment our left index. So now as we increment our left index, it will become 8, and here we will. So now 8 plus 8 is equal to 16, which is 8 again. So now mid is 8. So at mid is equal to 8. Value of our trips is 6, which is again equal. So now we will decrement our r. So now our r becomes 7. So as soon as our left is greater than our r, we will stop the loop and return the value of l, and that will be our final answer. So I hope that makes this binary search solution very much clear. So let us just quickly move to the code walkthrough to understand inside the code. And firstly, we will find the range in which our answer will lie. So our answer will lie in left is equal to 1 to right is equal to minimum element inside our array into total number of trips. And now we will run a loop up till left is less than equal to right. Firstly, we will find the middle element, and we will check if for that middle element, which is a time, if at that time what are the total number of current trips we can go to. So if the current trips are greater than equal to, we will try to reduce it. We will try to reduce it. So we will do mid minus 1 equals to right, and if uh, the current trips are less than total trips, we will increment our left index, and at the end we will return our left index to from the array, and that will be our answer as we have seen on the whiteboard. So I hope this makes the intuition and the code very much clear, and thank you so much for watching. Hope it has helped you. I will link both of the solution, brute force solution and optimized solution, and the pinned comment. You can find it there. Thank you so much for